Okay, so this is the second part of AI/ML and IoT. So here we are going to discuss technologies that drive IoT. IoT has become possible because of convergence of embedded systems like wireless, sensors, network, control systems and automation that makes connected industrial manufacturing factories, intelligent in retail, next generation healthcare, smart homes and cities and wearable devices possible, etc. Let's briefly discuss these. Sensors and actuators. Sensors are devices that can detect changes in the environment such as temperature, humidity, light, motion or pressure. Actuators are devices that can cause physical changes in the environment such as opening or closing a valve or turning a motor. These devices are at the heart of IoT as they allow machines and devices to interact with the physical world. Automation is possible when sensors and actuators work to resolve issues without human intervention. Connectivity technology. To transmit IoT data from sensors and actuators to the cloud, IoT devices need to be connected to the internet. There are several connectivity technologies that are used in IoT, including Wi-Fi, Bluetooth, cellular, Zigbee, and LoRaWAN. Cloud computing. Cloud is where the vast amounts of data that is generated by IoT devices are stored, processed, and analyzed. Cloud computing platforms provide the infrastructure and tools that are needed to store and analyze this data, as well as to build and deploy IoT applications. Big data analytics. To make sense of the vast amounts of data generated by IoT devices, businesses need to use advanced analytics tools to extract insights and identify patterns. These tools can include machine learning algorithms, data visualization tools, and predictive analytics models. Security and privacy technologies. As IoT deployments become very widespread, IoT security and privacy become increasingly important. Technologies such as encryption, access control, and intrusion detection in systems are used to protect IoT devices and the data they generate from cyber threats. Use cases of IoT applications: healthcare. In the healthcare industry, IoT devices can be used to monitor patients remotely and collect real-time data on their vital signs, such as heart rate, blood pressure, and oxygen saturation, etc. This sensor data can be analyzed to detect patterns and identify potential health issues before they become more serious. IoT devices can also be used to track medical equipment, manage inventory, and monitor medication compliance. Manufacturing. Industrial IoT devices can be used in manufacturing to monitor machine performance, detect equipment failures, and optimize production processes. For example, sensors can be used to monitor the temperature and humidity in a manufacturing facility, ensuring that conditions are optimal for the production of sensitive products. IoT devices can also be used to track inventory, manage supply chain, and monitor the quality of finished products. Industrial IoT is such an expensive new technology space that it is sometimes referred to by its own abbreviator, IIoT, that is Industrial IoT. Retail. In the retail industry, IoT devices can be used to track customer behavior, monitor inventory levels, and optimize store layouts. For example, sensors can be used to track foot traffic in a store and analyze customer behavior, allowing retailers to optimize product placement and improve the customer experience. IoT devices can also be used to monitor supply chains, track shipments, and manage inventory levels. Agriculture. IoT devices can be used in agriculture to monitor soil conditions, weather patterns, and crop growth. For example, sensors can be used to measure the moisture content of soil, ensuring that crops are irrigated at the optimal time. IoT devices can also be used to monitor in livestock's health, track equipment, and manage supply chains. Low power of solar powered devices can often be used with minimal oversight in remote locations. Transportation. In the transportation industry, IoT devices can be used to monitor vehicle performance, optimize routes, and track shipments. For example, sensors can be used to monitor the fuel efficiency of connected cars, reducing fuel costs and improving sustainability. IoT devices can also be used to monitor the conditions of cargo, ensuring that it arrives at its destination in optimal condition. Risks and challenges in IoT. While IoT offers many benefits, but it also poses several risks and challenges. Here are some of the most significant ones. Security and privacy risks. As IoT devices become more widespread, security and privacy become increasingly important. Many IoT devices are vulnerable to hackers and other cyber threats, which can compromise the security and privacy of sensitive data. IoT devices can also collect vast amounts of personal data, raising concerns about privacy and data protection. Interoperability issues. IoT devices from different manufacturers often use different standards and protocols, making it difficult for them to perform what's called machine-to-machine communication. This can lead to interoperability issues and create silos of data that are difficult to integrate and analyze. Data overload. IoT devices generate vast amounts of data which can overwhelm businesses that are not prepared to handle it. Analyzing this data and extracting meaningful insights can be a significant challenge, especially for businesses that lack the necessary analytics tools and expertise. Cost and complexity. Implementing an IoT system can be costly and complex, requiring significant investments in hardware, software, and infrastructure. Managing and maintaining an IoT system can also be challenging, requiring specialized skills and expertise. Regulatory and legal challenges. As IoT devices become more widespread, regulatory and legal challenges are emerging. Businesses need to comply with various data protection, privacy, and cybersecurity regulations, which can vary from country to country. Thank you.